We continue looking at the characteristics and features of the class diagram. You have relationships that are indicated with associations. Again, a line connecting two classes, and it represents the relationship between instances or objects of classes. It's like cardinality. If you've taken database courses where you talk about one-to-one and one-to-many relationships, it's very similar. In fact, it's the same thing as that. A student enrolls in a certain course, but courses might have many students. A course might have many exams, that sort of thing. There are two ends to the association, which is the line. There is the role name, such as enrolls, and there is multiplicity, which is the same thing as cardinality. One course can have many students. Also navigability. You can go, the association is such that you can move from one object to another. It can be unidirectional or it can be bidirectional. For example, here we have a university class or object, and we have people objects. And the role that the people play in this scenario, student. People are students of the university. But this person may also be, the university may be an employer of people. And also a teacher. University may teach people. Okay, the role names are specific to the ends to which they relate. There's a one here because people go to one university at a time, but university has many student people at a time. Person may have from 0 to 1 employer at the university. The university might have many teachers who are people. Okay? So here's the association, the line. This is the multiplicity. This is many, and this is 1. This is 0 to 1. And it's explained down here in these boxes. So here's a complete sample class diagram. This diagram is an example of an order system of an application. It's not the entire system. It describes a particular aspect of the entire application, that is, that relating to customers and orders. Order and customer are identified as the two elements of the system. They have one-to-many relationships. A particular order can only belong to one customer, but a customer may have several orders at a time. Order is an abstract class over here and has two concrete classes in this inheritance relationship. A special order is a type of order, a specialized type of order, and a normal order is also a child to the parent order class. This is abstract, meaning it has no instances or objects because it's at the top of the hierarchy. These are concrete because there are leaves in the hierarchy. So these two inherited classes, the inheritance flows down, have all of the properties of the order class. They inherit them automatically, but they also have their own additional properties. They inherit, confirm, and close, but this one, special order, has the dispatch functionality or operation, and this one has dispatch and receive specialized operations. Here's another class diagram, and it's not the same as the other one, okay? It's similar, that's for sure. Order, customer, we have corporate, specialized corporate customers and personal customers, and here we only show the unique attributes. We don't repeat. Customer has name and address and a credit rating. Corporate customer also has name, address, and a credit rating. We don't have to show that again, but they also have contact name, credit rating. It does show it again, okay? No, that's an attribute. Credit rating attribute, credit limit attribute. Remind operation, bill for month operation, okay? Personal customer has everything the customer has plus an additional attribute, which is credit card number. Note here we're showing order and order line. An order line can only belong to one order, but an order can have many order lines on it. Similarly, a product can be on many order lines, but an order line can only have one product. Okay, and we're also showing the constraints in this class diagram, which is with a notation. Visible analysts will allow you to do this. You add a little note for the constraint, and you can write it in. If order customer credit rating is poor, then order is prepaid must be true. Okay. So, and then finally down here, employee, corporate customer may have many employees, but an employee can only belong to, that is the Salesforce employee. Corporate customer can have many employees, but the employee can only belong to 0 or 1 corporate customer. There are two specialized types of relationships in class diagrams: composition and aggregation. So in composition is a whole part relationship, and it has some special characteristics. A part may only belong to one whole, and if the whole goes away, the parts go away. Okay, so here's a general representation of it where we have, note we're using the diamond that's the symbol you use to denote composition, where this is the whole and these are the parts. Okay, here's an example. Chessboards. You have a chessboard and you have squares on the chessboard. There's 64 squares on the chessboard. There is a multiplicity relationship here, that is, chessboard has 64 squares, but a square only belongs to one chessboard. Note that composition is really a strong form of association. Components, the parts, can only have one owner. Components cannot exist independently of the owner. If the chessboard is destroyed, all the squares are destroyed as well. Here's another type of relationship in class diagrams: aggregation. And note that aggregation also uses a diamond, okay, where this is the container. Aggregation shows container-containee type relationships. We had a diamond in composition too, but it's a filled-in diamond. Okay, so diamonds are used for both compositions and aggregations, but if it's a composition, which is whole part, it's filled in. If it's aggregation, it's not filled in. Okay, so here's the general. For example, a bag contains apples and contains milk. It's a part of association, but the parts can exist independently of the aggregate whole, unlike composition. Apples can exist with or without the bag. If the bag is destroyed, the apples are still there. Okay, and generally aggregations are, not always, but most of the time they are container-containee type of associations.